very good open question. I'll let you guys fight it out afterwards about how much right now you can get out of the math.
Great. Well, join me in thanking Hans. And I want to suggest for a few reasons, partly because lunch is still there, but also because I want this discussion to be like kind of non-hierarchical if possible. I want to suggest that we don't like bring the speakers up to the front or something like that, that we just have kind of an open roundtable discussion. At one point, I had entertained asking Carrie to kind of moderate it, but I want Carrie to talk, so I think I'll just like write down people's names, and does that seem fair, or do you want to go first, or? We had this email thing, and then I never actually did ask you. I was like, would you mind if I did in the future ask you to do something? And you were like, sure, if you did ask me to do that, I would say yes, but then I didn't ask it. So I don't know.
Want me to moderate? I will moderate.
I will moderate. Okay. You'll talk.
Oh.
You had a question.
I have a question. Well, I have a couple of questions. So, and thanks to everybody who spoke. Just going back to, I mean, this is something we discussed already. So going back to Dave's talk. So you're saying that identifying models that are categorically, or theories that are categorically equivalent is sort of gratuitously counterintuitive or gratuitously weird or something like that. So looking back at David's paper, so you don't commit to what the notion of mathematical equivalence is. You're like, you know, yeah. So what is it? Categorical equivalence is too permissive, and some other like intertranslatability is too restrictive or something like that. That seems fine. But what's for sure is that you're employing this kind of we know it when we see it, right? Sort of criteria for identifying particular for identifying the sense of recognizing particular cases. And so also looking at Jim's paper, the Compass article on theoretical equivalence. So you take more of a stance on like categorical equivalence being the way, and it seems that the main reason is that it can be applied to real cases, and it appears to render intuitively plausible verdicts in a number of cases of real interest. So you have one set of intuitions. Dave has another set of intuitions. A bunch of metaphysicians are going to disagree with your intuitions. Like, is there a way that we can move forward here? Like, is there something that different parties here can agree on? Do you think?
I haven't thought of it. I mean, here's the thing I would say now that I didn't say in that paper, and it speaks to what I was speaking about earlier. I think it's always going to be a mistake to suppose that we can take an uninterpreted piece of mathematics and directly say anything about it. Yeah, our physical theories are interpreted bits of mathematics. So what I want to claim is it doesn't follow from that they have to be interpreted in language. They have other interpretive tools where they're interpreted. Once we understand a bit of physics once we understand how mathematics is interpreted, we then have a kind of criteria of theoretical equivalence, which is something like, do we have a map from one mathematical theory to another already interpreted mathematical theory, such that we can pull the interpretation through the map. So I mean, in the language first context, for instance, if we have a theory of reference for our linguistically stated theory, and then we have a loss-preserving translation in the formal sense between that that linguistically stated theory and another, we can pull our interpretation of the first theory through the equivalence and now the interpretation of the second theory. So I think if one's got that starting point, one's at least got some resources to play with, and one wants to say, okay, there's never going to be a purely formal criterion for theory of equivalence if theories are understood uninterpreted any more than you could take two uninterpreted formal languages and ask what the correct translation between them was. But that's not going to completely solve the disagreements here, but perhaps it gives some slightly more substantive idea about what's being claimed when one wants to claim two theories are equivalent.
Yeah. So a thing I would just like to add to that is I think, and this is kind of what I took to be this is the point I was trying to get across kind of early in my talk when I was talking about how do you define the category of models, right? I think a further thing that is clear is that if you take a mathematical theory and you you interpret it only to the point of saying what is its empirical content. So it's models plus empirical content. But those two things together are still not sufficient to fix enough content for us to like, you know, be able to define, you know, for us to be able to like do business, you know. Whereas it seems to me that an assumption of the folks writing these papers about categorical equivalence is, if I take the math and I add to it empirical predictions, now I have enough information to say, what is the theory saying, period, right? Or what is kind of like, I mean, the way I would put it is the right way to interpret the theory, or the right way to kind of like the complete theory that does, you know, an adequate job of explaining those empirical predictions.
I see you, Jeff. I wrote my name down. Actually, I didn't, but.
No linguistic event.
I think there are two or three things I kind of want to say. So one is I don't care about categorical equivalence. I don't know if it was before or after that Phil Compass article, but I also did write a paper called "Why Not Categorical Equivalence," and I've gotten a lot of mileage since, having established both P and not P.
Many things follow.
So I think it's pretty clear that categorical equivalence is too permissive. I also think it's pretty clear, and this is something that Hans and I have talked about. In fact, we've talked about it so recently that I can't even remember if it was in his talk or if we just talked about it before his talk. It's something Toby and I have talked about too. In fact, also immediately before Hans's talk. All of these theorems that establish categorical equivalences in interesting cases between physical theories actually establish much, much more than categorical equivalence. They are sort of full reconstruction theorems. You give me a model of the one theory and I can construct a model of the other theory. That implies categorical equivalence in these cases, but there's an enormous gap. It's much, much stronger. And I take this to be what Toby is after here. Trying to come up with methods that allow us to capture what that extra thing is. I mean, how that reconstruction actually works and what it means. It seems to me that it's more permissive than Morita equivalence because the kinds of tools you have for doing the reconstruction are more extensive than the ones you have for Morita interpretability. But it is a reconstruction. So I think that there's just a really interesting, rich mathematical project to understand in each of these cases, almost like a kind of reverse mathematical like program. Like what are the minimal like resources for interpretation that are needed in order to realize each of these equivalences? Okay, given that, I want to sort of like double down on what David said about how much you get through these equivalences, given just how strong they are. So forgetting about categorical equivalence, given what's actually established in these relationships, I really do want to, I'd be willing to make whatever bets people wanted to make, that at the end of the day, once we understood how those reconstruction results can be understood logically, we're going to want to say that anything we can say about the world in the one case, we can say about the world in the other case. Anything that we should want to say about, anything we should want to say about what the content of the theory is on the one side, we want to say on the other side. To try to motivate that, I just want to say that I think that there are other cases that look totally mundane that have a very similar character to the Einstein algebra and relativity case. And so if you look at how David Malamud in his textbook defines manifolds, It's in a tradition that, Wald and Garrosh have also worked in, where you don't first define a topological space and then define charts on top of it. You just define the charts. This is a different definition from the standard definition of manifolds. I want to say that you get the exact same structure. There are reasons why you might want to do it this way. I mean, even philosophical reasons why you might want to do it this way. You might want to say, well, there's some sense in which topology isn't prior to the ways in which we coordinate points in space and time. And there's some sense in which you want to say that comes out of something with more direct physical significance. I would argue that what's going on in the Einstein algebra case, forgetting about metric stuff, but just the function spaces, is pushing that line of thought even further, saying, well, in fact, what's physically meaningful in the first instance is the actual possible distributions of, matter properties, say whatever mass density or ways in which scalar curvatures could be or something like that. But it's the same kind of argument where there's a kind of what we should take as our starting point and what we reconstruct from it is a little bit arbitrary. We can characterize that sort of structure in a few different ways to begin with. Now, I don't think that Dave would want to say that Misner, Thorne, and Wheeler and Wald are inequivalent theories because one of them starts with topological spaces and the other one doesn't. And I want to say that the Einstein algebra case is actually just the exact same thing. And in fact, Nestruev, who develops this stuff in the greatest detail, is exactly motivated by this sort of thing. I mean, the whole book is about the observable structure of geometry. And they think that these, smooth scalar fields have a kind of more direct physical significance than space-time points. They want to construct the space-time points from the fields. Okay, so Jeff.
So this is tied in with the conversation up here, so given what David was saying just now, it's not really math first. It's interpretive math first, right? We have a mathematical model with some degree of interpretation. Dave wants there to be some kind of rich interpretation of that mathematical model that goes beyond just the empirical properties of the model. So I'm curious, David, what's your picture of how interpreted that mathematical structure is? And right, a natural example to use, given our conversation in the last 10 minutes, would be quantum mechanics, right? What do we have over and above the Hilbert space together with the set of unitary operators on it that goes into that mathematical model?
So I think you missed my talk.
I did.
Yes, so that's my.
I was giving a talk.
I'm not complaining, but that was the 45-minute answer to the question. So I mean, let me just as the heavily abbreviated version of that. So it would be yes, interpretive math first, but I'm still going to hold on to the math first label because it was always interpreted language first. I mean, no one who had a language first conception of theories thought that theories were just uninterpreted lexicon and syntax. What do I mean by an interpretation here? I want to say that we know that we'll never give a full account of what it is to interpret a theory, mathematical or linguistic, without already presupposing the interpretive resources to do it. And so we can't explain how X represents P unless we can already represent P. So there's a circularity that's present also in theories of language, but it's not vicious. And what that generally means is that we come to learn a new mathematically formulated theory by a bunch of ways in which it relates to mathematical theories we already know, and then eventually you kick the ladder away and understand its own terms. But this is the short version of a thing I was defending.
But there's physical interpretation though, right?
Yeah, absolutely. Yeah, these physical theories are interpreted.
Yeah.
And this is Hans was arguing for this. The place I want to draw a distinction with what Hans says is from the fact that physical theories must be interpreted, it doesn't follow that an interpretation of a physical theory must automatically be a description in language as to what a physical theory is saying. As for the quantum case, I mean, this is a sort of narrow point, if you like. I mean, I want to say take our mature quantum theories, and they're just much more richly structured as purely as mathematical objects than you might think from some of the foundations literature. It just doesn't describe them well mathematically to say they're entirely characterized by something like a Hilbert and Hamiltonian. And quantum field theory, let's say, is going to be characterized by a space-time and a map from regions of that space-time into algebras on the Hilbert space, and then a vector on the space. and a whole bunch of assumptions that the symmetry group of space-time is represented in unitary transformations, all sorts of more sophisticated ways one can do it, but that kind of thing. And then a structure-preserving map of that is going to be something like a Poincaré transformation plus a map from algebras to unitaries, but for an assignation to any region R, or the unitary that takes the algebra of region R to the algebra of region lambda R. And that's an extremely rich structure that you have simply present in the mathematics of quantum field theory, that gives you a lot of interpretive resources to hook the world. And I think that rather than a preferred basis is what the actual formalism is delivering to us.
Well, but we understand not fancy quantum field theory, right? We understand standard classical quantum mechanics. And for that purpose, presumably we do use something like a physical understanding of what the open space represents.
So I think that's still a lot more structured, but I think there is some hybridness going on. I mean, so I think that, non-relativistic particle mechanics is structured by a compositionality structure on the space and by an action of the Galilei group, let's say, on the space. And that strongly constrains it. Now, what's not completely clear to me is how you would understand the action of the Galilei group and the relation between the classical space-time and the Hilbert space structure. I think that's non-transparent in quantum mechanics in a way that's transparent in quantum field theory. But I'm pretty relaxed about saying, fine, our interpretation of perhaps our interpretation of non-relativistic quantum mechanics always required a certain bunch of classical hooks that are not fully understandable. But that's okay. It's not. We've done much better since then.
Specifying particular basis corresponds to a.
It might, although I don't. It might, but I'm very skeptical that's the right way to do it. I think it actually involves some kind of vague, quasi-classical intuition about the relation between space-time symmetries and the setup. If I had to guess.
But it's curious that we don't know how to. Right?
Well, we do QFT
because we understand. But we understand quantum mechanics without moving to QFT and so on.
Well, I'm sort of neutral as to whether we can. I don't really care if we can. We got QFT.
This is super helpful. And the only reason I didn't catch the talk is I was giving a virtual talk at CNN.
Oh, I wasn't at all complaining. I just wanted to explain why I was giving such a brief summary. I didn't want to make everyone else's
the summary.
I see Neil. I think we lost sight a little bit of Carrie's original question. I just wanted to, come back a little bit because I think something that Thomas argues in his dissertation is that there's what you say about when theories are equivalent is a really good heuristic for what you take to be, like you take the project of interpreting theories to be. And it may just be that at the end of the day, there are disagreements about what the content of a theory is. And I also think, Dave, you were making some conciliatory remarks. Or like, no, actually you weren't. No, that's not the right way. You were suggesting that you endorsed some version of David Math First style structural realism. But I would have thought that if you were given your commitment to theories having building blocks being a really substantive part of the theory, like what the building blocks are, I would have thought that was just a litmus test for being a structuralist. Like you're not a structuralist.
Oh yeah, right. So one of the things that I think is nice about David's paper is that it doesn't seem to me to be very structural realist at all. Necessarily, it's that's just a name that's kind of it's lost a lot of meaning that it once had, I suppose. But so I think that a thing that I would add to what David says in that paper is that part of what goes into what he calls the notion of mathematical equivalence. If we're doing this stuff right, I would say yes to a lot of what he says in that paper, and then say, and in addition, the notion of mathematical equivalence has to include some stuff about which things are the basic building blocks and which things aren't, right? And you know, that's like I think it's entirely compatible with like the real substance of what he's saying, which is that like, you know, we don't need a first order axiomatization of everything, and physics doesn't need to be beholden to like constructibility in syntactic terms, right? This all seems right, you know. It's just like, but in addition, we need some notion of like worldly structure, and I don't think you can really have a notion of worldly structure without something that's kind of like a notion of joint carvingness, right? So, you know, like just put that into your math first picture, right? Like there's mathematical stuff that represents the basic building blocks, and there's mathematical stuff that's kind of like arbitrary, stupid functions of the stuff that's the basic building blocks. And we shouldn't put those two things on a par.
I was going to say just to make you fight more and not make peace too early. No, I think one thing in the spirit of what this David is saying, Wallace is saying, is that I actually think it does draw a line. Is I think there's a physicist intuition that's a mathematician intuition as well, that it's only the mathematically describable. I mean, I have a hard time, that sounds wrong already, but so there's these metaphysicians, right, who are like, no, I want to know the actual identity of the thing, right? This thing, is that the same as that thing? And physicists be like, if I can't see that in the math, I'm just not interested in it. So I do think there's a certain place where metaphysicians I know will say, I can't take mathematical first structural realism and just add a little more math that makes it okay for me as a metaphysician, because just a little more math is not going to capture that hexaetistic bit.
Yeah, I mean, you know, like, okay, I think that the thing that is a little bit odd about saying that it's all about the math in this kind of way is, you know, it's like, what does it take for this kind of gets back to what we were saying initially in response to Carrie's initial prompt, right? Like, what does it take for the math to be interpreted enough so that we are like saying stuff that has enough content for it to give a good explanation of, yeah, and I would say one of the things we need to say is which of the stuff in the math is basic building blocks and which isn't. And I mean, I guess, I want to illustrate this with an example. Some folks here, I'll be repeating myself too, because I talked a lot about this at the last PSA. But you weren't there and a number of others weren't. There's a kind of fetishization of mathematical isomorphism that gets done. And it concerns me because what counts as an isomorphism is relative to what are we stipulating to be the mathematical framework the theory is written in. And I could take a theory, for example, like I just take classical, you know, point particle mechanics, and I say, now I'm writing it in a different mathematical formalism while maintaining all of its empirical predictions. I stipulate that those are the same. But in my new formalism, I'm going to count as isomorphic any two solutions that have the same total angular momentum or the same total mass or something. So now I have isomorphic solutions that clearly differ in content because they differ in their empirical predictions. And there's no law of mathematics that tells me I can't.
I agree. And the thing is, you could always look, even your basic building blocks, you can always throw in I won't even say the word predicate. You can always throw in a subset of your model that is the subset of fundamental things. So that's true. I would say the math for structural realists can come that far with the metaphysician, but there's further that they can't go. And here's what I'm actually trying in my mind to draw the connection now to another. You know, I've heard all these metaphysicians talk about, you know, we're not interested in a purely formal data. We're not interested in pure, and that's what David Wallace is not going to give you. He's not going to give you something that's not purely. Look at the word purely formal, the phrase purely formal. Nobody understands what it means. So it's, but I know what they're getting at is right. Don't give me a mathematical definition. It's a metaphysics definition I want, and that's where I think. Look, I don't want to interpret. I'm not supposed to be the one interpreting David Wallace in the room. But that's my feeling is that you just not, when they say, I have a notion here that I can speak metaphysics language about, but you can't give me a mathematical picture of, you're going to say I'm not.
Because I think among us, I'm a pretty good interpreter for these guys. I think what they mean is that as a substantive thesis, a lot of them are ontological realists, and so they think that you do need to provide something like what Quine was saying that starts out with an existential quantifier.
Yeah.
Right. But I think somebody like Sider also understands that it's coherent to suppose that that's not true. And he as a substantive view of his, he thinks ontological realism is superior to alternatives. And I don't think that's true, right? So that's a place where I'm breaking with those guys, even though I agree with them about many things.
Harriet, you also had a finger.
Yeah, just on what you said about, is it Thomas?
Yeah, Thomas.
Thomas? No, it's Tom, sorry. I was just talking with Jeff about this. Like, I think, yeah, the notion of like equivalence of anything, like it's a weird kind of halfway house concept, right? Because it's somewhere between identity and mere similarity. So similarity, we all understand, you think of Lewis and Goodman and stuff, is a totally interest-dependent notion, totally contextual. Like, a rubber duck is similar to a duck for some purposes and not for other purposes. And so whether two things are similar, just in general, is very much an interest-independent thing. Whereas whether something's identical, to itself or not, that's kind of like a fact. It's not interest-dependent. Like equivalence is kind of in this middle, kind of in this in-between sort of space. So I think, yeah, absolutely, whether you're going to take equivalence to be, what you're going to take to be equivalent is going to be a function of, is going to be an expression of what you think is important in some kind of larger project. I actually think mathematical equivalence, like basically saying that there's no more to say beyond mathematical equivalent, is probably a perfect articulation of ontic structural realism for a bunch of reasons. Certainly construed structurally. So one, given that you say different mathematically equivalent theories will tend to mix up categories. I think, and that whether, which category is more fundamental than what is this really traditional, it's just a very traditional kind of metaphysical question. And insofar as they want to kind of subvert, so I think it subvert lots of metaphysical projects. So I think, for example, the first chapter of Everything Must Go, memorable one, I think it's absolutely constitutive of structuralism. A lot of methodology in contemporary metaphysics. And moreover, you go that route, you massively cut down on underdetermination, right? Which was also always a huge part of the structuralist project. I think it would be an interesting question about whether this approach to structuralism is actually better at cutting down underdetermination than the old one of chucking out an ontological category, namely objects, right? So, with the old Stephen James stuff, like, our particles, individuals are not individuals, so like, we'll chuck them out and it doesn't arise, so you don't have underdetermination. But it's actually, it just seems you've just proliferated underdetermination, right? Because you have like fields, objects of individuals, objects of non-individuals, all these new objects, right? It's really not clear.
And in Simon's point to you, about Simon Saunders' observation with you, the Ramsey sentence version of classical electromagnetism is not going to happen QED to the Ramsey sentence version of QED any easier than the original one.
Yeah. I think personally, I think there is a ton to like about this as like an approach to ontic structural realism, and that idea of theory equivalence, but only because it's in this whole big constellation of what you want your metaphysics of science to look like. And I think without that, then we just get into this sort of intuition trading, saying that you should like this because it's extensionally adequate according to somebody, but then you're like, well, no, it isn't, because that doesn't sound right to me. It's just, we can only pick what the right criterion of theoretical equivalence is by saying, like putting it, as I say, in a broader context in which you can evaluate claims about similarity and So yeah, I think I think you can't answer this question about whether theories are equivalent or not independently of specifying purposes. And ontic structural realism, just looked at as a whole package, has all these things that it wants, all these things that it likes. Going back to the point, about Galileo and the two books and stuff, I think, you want to say like that there's something about that moment when science starts making progress, and that has to be taken really, really seriously in metaphysics. And for all these scientific laity who want to like express things in other ways, like you say, speak for yourself. You don't. Which doesn't say it's going to convert anybody that doesn't share those sensibilities, but that's fine. But that doesn't mean, and as you say, I think in the paper, you're not trying to convert people to ontic structuralism. You're saying this is, I think, the right way to think about it. And I think that's totally right.
Yeah. Well, Neil had a question, if you want.
Just quickly, Pat. I mean, so here's my kind of like what's purpose thing. And my answer would be doing physics. And I mean, there's a kind of style of talking about physics that we've been using a lot in this meeting that's very much sort of radical interpretation. Community of physicists, and we need to make sense of their bizarre utterances. I kind of flatter myself I speak physicist, and I want to understand how to think about theories just in a way that's adequate to what we're doing in physics. And I'm really skeptical about the idea that we could have completely finished the exercise of physics and sorted out all the conceptual problems that physics thinks are conceptual problems, and there'd still be a substantial residuum of controversy that we could have interpretationally that's a further task for philosophers of physics. And I think a lot of philosophers of physics think exactly the opposite, that philosophy of physics starts off when physics is all done. And I think that, that disagreement, I think, is pretty foundational. I suspect Jim's probably closer to my take here.
Mm-hmm. Neil?
Yes, this is different to the observation I was going to make first, that it's just so prompted by this conversation about, kind of theories showing what's fundamental or not. And this is something Thomas and I were talking about in coffee break. I mean, one interesting, I don't know, that these claims aren't, it's not just that these claims aren't in the mathematics. There's like an interesting sense in which, so insofar as you're taking these claims about what's fundamental to be coded up in what formalism you're using, or what terms you're taking as primitive, or maybe what axiomatization you're using, if you want to think about what facts are fundamental, which facts are derived, which a lot of people, particularly in the more metaphysical end, do want to kind of take that to be the way you code these things into your theory. There's like an interesting sense which, there's then no proposition of the theory. There's no assertion within the theory that says this is fundamental. Right? So you could appeal to a kind of Wittgensteinian saying and showing distinction and be like, look, the theory shows that space-time points are fundamental by using a formalism based on space-time points. But you get this interesting observation then these like kind of metaphysical parts of the theory stop being part of like the propositional content of the theory and become something like its displayed character. I just think it's kind of, seems cute.
I think I was with you up until that last bit.
Oh, sorry. I don't like. Maybe that's one of the things that makes people hesitant. I think it makes me hesitant about using, like, taking those things to be kind of contentual is to some extent the fact that they reside in the mode. I don't know, switch to kind of Frege metaphor rather than a Wittgensteinian one, in the kind of mode of presentation. That seems like maybe a little troubling, that if you're sort of skeptical that there could be real physical content to that as opposed to cognitive content.
Mm-hmm. There's a connection here to something that Toby said that I was hoping Toby would say more about. You use this expression strong logic a couple of times. Mm-hmm. So there was one way of understanding what was going on. Well, let me put it this differently. I didn't understand what was going on. Might have been going on was that, so often in JB's work on foundations of general relativity, he's considering, restrictions or expansions of the things that people normally think of as the space-time, right? So people, you give a definition and
you give a nice distinction between definitions and axiomatizations, you give a definition of what a relativistic spacetime is. And then you can say, but we're going to just consider the ones that are, inextendable, or the ones that have certain causal structure or something like that. Because those are the ones that we think are plausibly going to represent real situations that are physically reasonable. That's not what JB normally does. He does the opposite. But they're saying, well, we're going to look at the transitive models. It looks a lot like that.
The non-JB way.
The non-JB way, yeah, but saying, look, we're going to just restrict attention to some of these models. I don't know how to, I know I can't say that in a first order sentence that I add to ZFC, but I can still sort of direct your attention to those.
Yeah.
Another thing though that's happening sort of at the meta mathematical level is like what Neil is talking about, is kind of, remarking about properties of the models, and the sorts of things that Hans was talking about is like ways in which talking about properties of models can go really wrong, is when you start talking about things that are like clearly not part of the intended content of the model you're talking about. Now, so I feel like I'm inclined to say that these epiphenomenal features of models that Dave wants to hang his hat on are more like the ones that Hans is saying are problematic. But I'm worried that maybe they're actually just things that are somehow related to strong logic.
So how do we tell good meta-mathematics from bad mathematics?
Yeah, like
So I didn't mean that as a joke. So the strong logic. So yeah, it is. You are essentially saying phi in a language of M being some structure, but you usually put some reasonable conditions on it, like it's going to be closed under isomorphisms and things like that. You can do it internally too, which is what the Varnanen does, which is like introducing quantifiers, but I don't set theorists, so I'm going to do it Hewitten's way, which is just by doing it externally. Are you going to be worried about they're going to be, well, I'd say M is equal to M and the continuum hypothesis. I think I would just bite the bullet and go, yeah, we can't fix it. Don't worry about it. Because what you're doing, the pathology in that example comes in because the undecidability of the sentence. If it was any other sentence, and it has to be a sentence to get this weirdness, so you add like any other theorem that'll speak, and true. It's just trivial. It won't do any damage, or it'll be false and it'll be the empty property. So it'll be the empty logic or all of them.
Okay, that's one class of Hans's problems, but that's not. So the question is whether the sorts of things that Neil is talking about, like, it's a feature of the theory having been formulated in this particular way that these things are the fundamental ones. Is in some sense sort of a commentary on something about the models that doesn't happen inside the theory, sort of happening outside the theory. It doesn't really seem to me to have the same character as saying, well, actually, we're just going to look at the transitive models. But I don't know what the limits of what, with the strong logic.
So how would we, maybe I'm missing, so whenever I hear fundamental, sometimes I just static.
I'm talking, like every few seconds you're zoning out. You're like, I don't know what he's talking about.
Doesn't really fit in math very well. I suppose I can see it
surely
maybe.
it's the signature, right? Surely it's the signature. It's
No.
the things that we take to be
because
the basic.
But it shouldn't be, should it? If we think that there are theories in different signatures and they're definitionally equivalent, we think they're talking about the same stuff, then we're fundamentally, if we're on board with that, then we don't think the signature is particularly significant at all.
But that, I think that, so those are the
I
things
think that could be an
saying
answer.
Yeah, so there could be reasons that you.
So I think there is a sense that like, at least, yeah, it's certainly very tempting, I think, sometimes to take which signature is being used, which terms are being taken as fundamental. So to take the facts about the signature to be codifying metaphysical or fundamentality.
Yeah, I just want to hide at that point.
Similar, but I think that's maybe one way of thinking about what Dave was kind of suggesting. I don't know.
I mean, it may make more sense in physics, I think. I mean, but in math, I think this sort of thing is just you're looking for like a heuristically good way of articulating a certain kind of mathematical theory. I can't see it gets more substantial than that there. But we don't pin things to the real world in math. So I mean, we talk about differences between the activity of making physics theories and theories in mathematics. This is one of the big differences.
I see, but I think what I'm hearing is, Ainsley's point is, look, of course we can talk about the signatures of theories. We can compare, what signatures theories are written, and it's not like that's somehow off limits for mathematical discussion. It's just, it feels very, very unnatural to have such a fine-grained notion of equivalence that you would distinguish between theories that are intertranslatable but happen to be written in different signatures, as in fact any intertranslatable theories must.
It depends what you're trying to do. So in mathematics, though, there are trivial examples. So if you go and dump in every definable relation you can, then your theory trivially has quantifier elimination, which is usually a desirable property. So it's a stupid thing to do, but so it can make a difference. So the signatures can be very relevant to mathematical problems, but so I think this is coming back to Kerry's idea. So equivalence is always about has to always be about a use. There has to be that has to be made clear. But nonetheless, some of these properties, like definitional equivalence, if you ever find it, you should definitely look at it and think about. If you don't know what the philosophy is, you should have a look around and see if there is some.
So we have, in fact, gone 15 minutes over what was supposed to be the end time. So there's a dinner for speakers at starts at 7. It's like a 15-minute drive away. And Clara and I have cars, but I think we probably are going to also need to get an Uber. It's sort of up to the group whether we stop now, reconvene tomorrow. There's a pub on campus we could go to for an hour or something like that, and just hang out as a larger group for anyone who wants to come along, or continue in this format. I guess I know what I vote for. Yeah, pub?
No.
Okay, well, we'll reconvene tomorrow, breakfast again at 8:30 and first talk at 9. And thanks again to all the speakers and this great discussion.
Sorry for
No, but I think like I was kind of saying it as like so we kind of know. I think it's like the highlight like anything is something else that you have to take
very brave.
But not today.
I mean that in like a.
Actually, right into the lion's den.
Round right.
Don't worry, when we come back to logic 7, I'll take which one is free out. Okay.
I got the button wrong of the article, so thank you for saying.
Oh, good.
The ones in the meta sentences and what I got sent. Dave. Yeah, David.
The irony is that my whole talk is about.
Well, I mean, if you look at the way so my book kind of assumes you can understand what mechanics at the initial level, and then you're effectively partly something and I'm treating quickly to the QT and constantly now I know how to do the testing.
I see how it's not good, like the infrastructure. Just all kinds of relationships.
Sea glass.
I say very early in the book
I just want to email from Sophie.
that any formulation of any specific concept a lot of the
Too much stuff.
as well as
Yeah, oh yeah.
Wait, this is the connectors of
Oh,
what's the
ready? Limitations of language, once again. I don't know if it has a name. Great term.
I grew up with both.
I should visit the.
There's Tim and Eric.
Yeah. It's just like. Even though, again.
You weren't
I was saying I'd rather do Halloween stuff.
I didn't know.
No, I've got boarding.
Yeah, it's like values and stuff. Yeah, it was. I would like to read,
That would be great.
maybe after spring or something. I mean, maybe it's in the past. But yeah, it's very. I read tons of something that I never do any. One of the reasons that I think it's like this basic social dimension. I feels like a little holiday. And that's all this is.
I get that.
Oh, yeah, you did the chat stuff, yeah.
And you want to lead people over to the.
Yeah, no maintenance. Yeah. Absolutely.
Hey Clara, did you lead people to the pub?
Yeah, these are hard deadlines. I just think stocks and
And there comes a time in learning that you understand the theory. And the only way to really
exactly, probably like go back and explain that. And like, it's like
And going. Yeah, okay.
I gotta take you. Clara, why have you?
they always
Let's discuss this. Neil, do you want to go to the pub?
Yeah, okay.
and the claim is
Under control. I sat down. Yes, no. Of course. I can't hear the jury.
Yeah, it's like right.
Now I don't sound
Yeah, I mean, in a sense, the ledger might be true.
It's not like a read. What do you think?
This is, yeah, so this is kind of a, it's kind of the language doesn't come.
Might have the same This is contact, but so yeah, it doesn't actually, so I mean, I would like literally just say about the day, maybe it's just an entire like topic. But I was like, well, it's too late now. I just, yeah, I have to do it. Yeah.
So you might tell.
My car is, I told.
Oh, I just, funnily
My
enough,
car is
the,
at my house and
Yeah.
bikers.
So there's this kind of like little historical project popped up in this of being like, I mean,
We are, and this
why?
also fills.
When did
So I don't see.
start going so on? Right? They're changing from like the contact
Into this process
representational view
of
to the
having
like
theory.
strong metaphysical representation.
That we
I
can
was like, what happened? And that made like, it's not that
We
they're
have a
making
bunch
one
of
people
different
was
ways
one
of
of the
interpreting
lost
that. There's
people
nothing wrong
in
with
its
that.
foreign
All of that stuff can be.
And then so I was actually looking at maybe coming to visit
So this helps me understand.
Princeton, because that's where the data is.
Which was very
Processing it, his letters, about that, or they were talking about. And I'm like, well, you know, no textual evidence, but I feel like, yeah, that would have been something that they were covering. Maybe on the opposite side.
Just by and persistent.
Yeah, and it's like, and it really cares about ability to program media. Oh, that's very true. And I'm like, what? You guys just tell me
You don't have something and an electron did this, and you try to give it, you might say, for instance, you might say, why is it that the charge? Then just when because then how do
I'm in the time, it's trying to how, yeah, so, yeah. Literally advanced this.
they're good for communicating.
Yeah, all I'm saying in here, kind of space time is, like, take this over here, it's conference here now. There's no other members, and I can have this. So I was like, what happening one time? And I'm saying that's true for every event. That's what Irvine Smith would say. Every time you have a new event, you want to get something like
So there's.
I'm just making.
So they're planning.
Everyone, I have to lock the doors, so I did, like what we did out underground.
Yeah.
And then he came back and
And if you take that same example, like, which I think is strong thesis.
and that was the idea that I wanted.